Hey there, in this video we're going to be doing a titration video. So I'm going to be off the screen so we can focus on what is going on down here. And so with a titration is actually a neutralization reaction in acid-base topics of chemistry. And so if I have something like a known solution of acid and I have something like an unknown solution of the base, then what I can do is I can use a mathematical formula after I see a change occur, and I can determine what the known, or excuse me, I can use the known concentration, I can calculate and determine what the unknown actually is. And so one of the key things you need in order to do that is an indicator. So in this lab, I'm using phenolphthalein. And what we have here, we have a burette, okay? This is a tall, very thin, almost like a graduated cylinder, but it's actually flipped upside down. So down here, instead of being the number 0 and working our way up to 25, 25 is actually down at the bottom and the 0 is at the top. So as we start to remove some of the liquid and as it goes down this chamber, I can determine how much liquid I'm actually using. So right now it is empty. I'm gonna close up the valve and I'm gonna pour in some liquid, and I'm pouring in the base, and I'm gonna go beyond the 0 line because there is a little area in here that has some air. And so we wanna make sure we drain out that air pocket. So I'm just gonna open this up and let it flow through a little bit till it gets down to about the 0 line. Now you can't see it because it's off the screen, but I'm a little bit below 0. I'm actually at 0.2. So I'm gonna write that down on the board out of the way here for a second. So I'm starting at 0.2 milliliters, and I know that's my starting point. Now, I know the titration is going to be complete when I have a known volume and a known concentration, and I can compare it with the other one. So in the Erlenmeyer flask, I'm going to measure out 5 milliliters using a very small graduated cylinder of the acid, and I'm going to carefully do this and maybe take out a little bit with a pipette just to try to make it as accurate as possible, because the better and more accurate you are with your volumes, and then the volumes you also are taking from your burette, the better your overall result's gonna be. So I'm a little bit above the 5. I'm gonna take some acid out here, so bear with me for a second. All right, so I'm about just perfect. Now, one of the things to consider, even though I am right at that 5 line, I'm reading the bottom of the meniscus, even though I claim to pour 5 milliliters in there, well, we have to consider one of the errors that often happens in science is that we don't always get exactly what we're looking for. Because even though most of the 5 milliliters went in there, I still have some that stuck residual because of, things like adhesion, cohesion, sticking to itself, but also sticking to the actual chamber. So your results aren't always going to be perfect, but we want to be as close as we can. So I have 5 milliliters of acid. Notice it is clear. And I'm going to take and put anywhere from 3 to 5 drops, depending on how fast it comes out, of the phenolphthalein indicator. Now, if you don't put an indicator in with your titration, the reaction will never happen. You could have this whole chamber come down and you'll never see a change. So I'm going to just mix that up a little bit. And we notice it's clear. Now, the indicator will be one color when hydrogen ions are present. And so Arrhenius stated that acids have a hydrogen ion present as the positive ion in a solution. And so I'm using hydrochloric acid, so hydrogen ion is the present ion. Arrhenius also said that hydroxide was the negative ion in our base. I'm using sodium hydroxide, so we have that negative ion present right there. So once I introduce the hydroxide, so the hydroxide's up here, the hydrogen is down here. We have to remember this is a neutralization reaction. So every hydroxide that's available will react and bond with a hydrogen and form water, which is one of the main resulting products of a neutralization. So once I start to turn the valve and we start to add liquid, it's starting to drop down, and maybe you're not going to see it yet. It might be hard to tell, but it's about right there. It's just above the line, so you're not seeing it yet. But there was some pink that was starting to show up here. And I'm using white just as reference so you can see the color. Phenolphthalein turns from colorless or clear to pink when it becomes basic. So around pH 8 or 9, it will start to turn pink. So what happens is every time the hydroxide is coming down, it's contacting the hydrogen and neutralizing. But if there's excess hydroxide coming in and there's no more hydrogen at the top, then the hydroxide starts to react and we end up getting a change in color because there's a lack of hydrogen. So you might start to see some pink, but what we're looking for is for the whole thing to be pink. And so if we notice, there is some pink color going in there, and it'll stay there, but it will start to fade away. And if I give it a good swirl, that's going to introduce fresh hydrogen from the bottom up into the top, and will cause that to react and go back to that clear point. Now, right now, I'm right here. I'm still above the viewpoint of the video, so I'm going to add a little more. We're going to keep dripping it in, and what you should do is really stir it the whole time, slowly drip. And what you're looking for is for that nice light pink color to stay. And when you have that color stay for a long time, maybe 10 to 15 seconds where it doesn't go back to clear, then you know you're probably done with your titration. And so once it stays longer, I'm going to turn this on for a little bit just to show you how much of a difference it goes. But we're going to swirl this around and notice it goes back pink. But I'm getting really close. Right now, the volume is right in there in your view almost. It's just getting there. So I'm going to start putting a little bit of a slower amount, see if we can get it to stay a little more pink, and then I will shut it off here. So I'm going to turn it off. Notice it is staying pink. It's a little bit light, and it may actually go all the way clear. We're going to ignore any pink that's on the glass. So notice it did go back clear, so that means I'm not done yet. So right now I'm down to about here. So I'm at about 11.7 milliliters, and I'm going to try to put very slowly 1 or 2 more drops in there, because sometimes it only takes 1 more to get it go beyond that line of where it's neutral. So I'm going to just stop at that. That was actually 3 drops. And if we add more drops, it'll just end up getting darker. And I'll show you what that looks like as well here in a second. So we're going to swirl this around. Notice I'm not putting any more in. The valve is perpendicular, so that's off. Hopefully you can see that now that that is off. If it's parallel, that's on. And so we've been at least 10 seconds now. It is still stayed pink. This is a nice faint pink. If you could get a little fainter, maybe if I had only done 2 drops, I think a 3rd drop did sneak in there. At the very end, it comes very close to where you are going. So right now I'm going to take a look at my cylinder. And again, it's just above where we're at, but we are at about 11.8. Now remember, you're reading a burette backwards. So it might have passed 11, but it did not get to the 12 yet. So I need to see how many lines past 11 it is, or how many lines above 12 is. So it's about 2 lines above the 12, which means 11.8. So if you remember earlier, I said we used 0.2. So I said 11.8. I'm just going to write this on the board. Was our final volume. And so I'm going to go over to the board here in a second. We're going to change the video, so please bear with me. But notice it's still pink. So this is a really good example of the color that we would want. Now, what happens sometimes is people get a little bit excited. Maybe they press it wrong, and they're not paying attention, and more goes in, and they end up having too much. And this is one of the examples of an error, where I still have a pink color, but notice it's a lot darker than what we had before. And that's why we would normally do 3 or 4 trials when we do this. This is just 1 trial. I'm just going to show you an example of what 1 trial is, and then obviously we would want to have multiple trials for that setup. Now, just to show you the concept of neutralization again, if I were to take some of that acid, and if I were to put some of that acid back in, just a couple drops, notice it starts to get a little clearer. Obviously I put a lot of hydroxide in, notice it gets clear again. So I only put a little squirt in there, and so you can see that we can go back and forth with the introduction of more hydrogen, it goes back clear. If I'm putting in hydroxide, it goes back to pink. Now, if we were going to do this over again and we were going to do a second trial, this would be my new starting point, and I would go through the whole thing again. I would dump this all out, I would rinse it out, clean it out, and I would start over with a fresh new 5 milliliters of my acid and then compare it. So what we're going to do, excuse me hitting the chair there, I'm just going to adjust this, and we're going to come over here to the board for a minute, and please ignore some of the other things that are on the board as far as dates and such that are left over. So I'm gonna have a seat here, and we started at 0.2 milliliters. We are going, and we went to 11.8. So basically we're just gonna subtract those. I used 11.6 milliliters of base. Okay, that's how much I actually added in to the material to neutralize it. And so what we're going to use a formula MaVa equals MbVb. Now, if you're in New York State, if you're taking the New York State chemistry regents, you will recognize that as one of the formulas about halfway down on table T on the back page of your chemistry reference tables. So we knew the concentration, if you go back to the beginning of the video, the concentration of the acid was 0.1 molar, and I used 5 milliliters of that. We did not know what the molarity of the base is. The base was our unknown, but I just used 11.6 milliliters of that material. So if we want to do the calculation and we want to solve, we're solving for MB. That means I got to get rid of the volume over here on this side. So that means I got to divide this side by 11.6, and I'm going to divide this side by 11.6 milliliters. The milliliter unit will cancel out, we'll be left with our molar. So really you're going to get 0.5 divided by 11.6, which again, my unit will be molar. And so we're going to get some value, and from the classwork we did before, something about 0.05, 0.04, something in that range. So you could easily do that and calculate on your own. I don't have a calculator handy right here, but that is the process. Again, we have a volume that was used. We may need to determine that. We're going to plug that in and substitute that into MaVa equals MbVb, again, molarity or the concentration of the acid, times the volume of the acid equals the molarity or concentration of the base times the volume of the base. So we started out with 0.1 molar acid. We had 5 milliliters of that. And then we took the unknown base and we used 11.6 milliliters of the base. We're just going to divide by 11.6 on both sides, do our math, and then we'll have our answer. So that is titrations and a neutralization reaction. Thanks.